Hi everyone, it's Mrs. Bebo. In this video, we are going to be talking about equations of proportional relationships. For my students, this is specifically for lesson 1.5. For those that are not my students, again, if you're learning about equations of proportional relationships, this video is for you. So our main goal with this video is to basically, how do you write an equation for a proportional relationship? And it just comes down to a simple equation. Y equals kx. So proportional relationships can be represented by an equation in the form y equals kx, where k is the constant of proportionality. So in a previous video, we talked about the constant of proportionality in a graph, and then in a prior video to that, we actually talked about the constant of proportionality in a table. So today we're specifically looking at equations, but again, it's all directly related to where k, again, is that constant of proportionality. And remember, two quantities are in a proportional relationship if they have a constant ratio between them. And so this k has the same value as that consistent ratio, and it's also the same as the unit rate. I did see that in some other textbooks, or for example on Khan Academy, they are using a different variable for the constant of proportionality, such as r. So just keep in mind, like my video might be using the variable k, which is what my students are familiar with. If your textbook is using something different, then just try to mentally replace that variable with the one that your book is using. Or if you're familiar with Khan Academy, again, k is the same thing as r. So keeping that in mind, it's in the form y equals kx. If we just remind ourselves again what we've learned so far about proportional relationships, we've looked at the fact that, again, it's proportional when you have this constant ratio of y to x. And again, it's this constant value k. So again, that ratio of y to x. And if I write that off to the side, again, remember that meant k is equal to y over x. We have our equation that we just mentioned, y equals kx. And so if we take an actual example, in this case, y equals 3x, this value right in front of x that's being multiplied, that is your k value. K equals 3. And if we were to solve quote unquote this equation for 3, so basically rewrite it so that it says equals 3. If I were to rewrite this by dividing both sides of that equation by x, it would actually say y divided by x is equal to 3. And remember, y over x is our k value. So it's just stating again that ratio between y and x is this constant k value, or constant of proportionality. And then finally, taking a look at the graph of the equation y equals 3x, if I were to pick a point on here, such as this one here, it's at this nice intersection, that is the point 1, 3. And so remember, again, 1 is representing our x value, 3 is the y value. If I were to write the ratio of, again, y over x, we'd have 3 over 1, which is the same as 3. So proportional relationships are always going to have the form y equals kx for their equation. So with that being said, let's jump into our first example. With this first one, we're going to identify the constant of proportionality in an equation and then explain what it represents. So this one says Olivia bought 6 containers of yogurt for $7.68. The equation y equals 1.28x, or 1 and 2800x, can be used to represent the situation where y represents the total cost of the yogurt and x represents the number of containers bought. So we're going to identify the constant of proportionality. And remember, keep in mind, our equations are always in the form y equals kx. So if I were to rewrite that equation that they gave me right underneath this, the value that is now replaced is k. So this number here, that's k. So we would say k is equal to 1 and 2800ths. Now, what does it mean in this situation? Well, remember, k is our unit rate. So we know it's going to be something per 1, right? It's a unit rate. To help you figure out, is it cost per container or the number of containers per dollar, right? Because those are the two quantities that we're talking about in this situation. Remember again that k is equal to y over x. So y, they told us in the problem, that is representing the total cost. So this is going to be our cost, in this case dollars, over the number of containers. So this is number of containers. I'll just use our hashtag symbol for that. So if I add labels to this, this is just saying it's $1.28 per 1 container of yogurt. So when it says explain what it represents, you're basically just adding labels to it. What exactly is this constant of proportionality talking about? In this situation, the fact that it's $1.28 per container. All right, so let's take a look at another example where we're going to do something very similar. An airplane travels 780 miles in 4 hours. The equation y equals 195x models this situation. What is the constant of proportionality? So once again, if I remember again, y equals kx, and I take a look at the given equation, the value that is replaced, y and x are still there. The only thing that changed was k. K actually has a value. So my k value is 195. So we didn't even have to write the equation for these questions. So don't overthink it. Literally, they're always going to be in the same form. Y equals kx. It's as simple as just picking out what is the actual number that is representing k. That's your constant of proportionality. Now, when we're asked to explain what this represents in the context of the problem, again, that's when we're just adding some labels to it. So before we even look at our A, B, C, D options here, again, remember what we're looking at in the situation. We're doing miles and hours. This one doesn't really tell us what Y and X are representing, but if we were to figure out the order in which they essentially divided these two here, right? 780 miles in 4 hours. We know they did 780 miles, just from our math knowledge, that they divided it in this order, right? 780 divided by 4 is going to give us 195, not the reverse order for that division. So what that tells me is that 195 is representing the plane speed. So they're doing 195 miles per hour. And so again, it's just a matter of figuring out what is your y value, what is your x value, or in a case like this where they didn't tell us that information, all we need to do is figure out, well, what order did we divide to come up with k? Because remember, it's always going to be y divided by x to get to that. And so in this case, we figured out, all right, it's miles over hours, so miles per hour. And so our answer for this would be option D. All right, so we're going to do one more of these, and then I'm going to do a part 2 for this video where I'll go into specifics on how to actually write the equation and then use the equations of proportional relationships. So last example for this video, again, we're going to identify the constant of proportionality. So in this one, it says Robert typed 2 pages in 15 minutes. The equation y equals 7.5x can be used to represent the situation where y is the total time and x is the number of pages typed. So part A, find the constant of proportionality. Again, hopefully at this point you're starting to memorize it. Y equals kx. And so if I look at that equation, I match it up with the general form, y equals kx. The value that's replaced for k is 7.5. That is your constant of proportionality. So we're going to describe it. And again, if we're not sure, which value goes where, because we know it's a unit rate, right? 7.5 is a unit rate. But is it minutes per page or pages per minute? Again, to help us with that, remember, again, k is equal to y over x. So think about what each of those values are representing. Y is the total time, which is in minutes. So we're going to have minutes over, and then number of pages. And so this is going to be pages. So it's minutes per page. So we can type, we're not reading, but we're typing 1 page every 7.5 minutes, or you could say it takes 7.5 minutes per page. All right, well, that's it for this video. Thank you for watching. Make sure you check out part 2 if you need help writing a proportional equation from scratch, as well as how to actually use a proportional equation.